Right, welcome guys to day 8 of month 2. I hope you are all ready for today's lecture. Right. So for today's lecture, we're going to be looking at something called recursion. Right. This is going to be today's topic. Right. So we're going to look at recursion. So this is a very important topic to understand. We will, most of the times are going to encounter situations that just need recursion, right? So, right. So, it's one of those programming concepts that may look strange when you first see it, but the basic idea of it is actually simple. It's simple and straightforward, right? So recursion is just a function calling itself, right? It's just a function calling itself, right? That is recursion, right? So a recursive function is a function that calls itself while solving a problem, right? So when you create a function, then inside that function you call the same function that you just created. That is a recursive function, right? So your question right now is, if the function calls itself, doesn't it just keep calling itself forever? So won't it be stuck in a internal loop, right? But the answer is no, it won't. A recursive function needs a condition that tells it when to stop. So if it doesn't have that condition that tells it when to stop, then it's going to be an eternal loop, right? So a recursive function, right, it does some of the following, right? Do some work, right? Call itself, right? And then eventually reach a stopping condition, right? So this is a recursive function, right? So the stopping condition is called a base case, right? So when you hear the word base case, always know that it's a stopping condition, right? And then the part where the function calls itself, right, is called the recursive case, right? So base case is stop, recursive case is continue. Those two ideas are the foundation of recursion, right? So okay, any question? Okay, so I want us to start with a very simple example, right? A very simple and straightforward example, right? So let's create a function called count down, right? Number, right? If number is equal to 0, right, print done. Return nothing, right? So then we print number down here, and then now call the function countdown equals to what? Number minus 1, right? Then you call the function and you assign 5 as an argument, right? So what happened here is that we created a function called countdown.
Yes, I can. I think he muted his
Oh,
his mic. His mic is on mute.
oh, I'm sorry, I didn't notice that.
Yeah.
Apologies. All right, so let me repeat. Here we created a function called countdown, right? And it takes a parameter called number, right? So then we have what if number is equals to 0, right? So this is our base case, this our stopping condition, our base case, this on line 12, right? So then we have what print done and return, right? So this plain return, it exits what the function, it tells the function that what we are done, right? Then we have print number, right? So this means that if the number is not 0, we print it, right? So this will execute if the number is not what? 0. Because if the number is 0, then we exit the function because of this return keyword, right? But if the number is not 0, we print it, right? Then here we're now calling the function, right? Countdown number equals to 1, right? So here we're supposed to use the same variable as this one, right? So this is the recursive case, right? This is the recursive case on line 17, whereby the function calls itself, right? Now we don't call the function with the same number. We call it with what? Number minus 1, right? So here we now what? Call the function and assign what? The number 5 to that function, right? We're all still together.
Yeah.
Okay, great. Okay, then that's great. Right. So, right, what we expected to happen here, right, is something like this. It will start like, for example, let's say countdown is 5, right? Countdown is 5. Then it prints what? Print 5. Then count down turns to 4. Then it prints what? 4, and so on until what? It prints what? Done, right? We expect it to do that Why? Because when we start the function, right, we're going to assign what? The number 5, right? So here to start the function is what? Number 5. Then it checks if number is equal to 0. Print done, return, right? But if the number is not equal to 0, we just print the number. Then we call the function again. This time we are going to say what? The number, the current number minus 1. If the number is 5, we are going to say 5 minus 1. Then it does this again. If number is now 4 equals to 0, no it's not. Then it's 4 minus 1, 3. Does this, it's not. And then it's 3 minus 1, 2, 1, 0. Until we get what? If number equals to 0. Right. So let's run the code and see what happens. See, if you look at my terminal, it printed what? 5, 4, 3, 2, 1. And then it printed what? Done. If the number is equal to 0, print what? Done. Right. So you notice that every time the function calls itself, the number gets what? Smaller and smaller and smaller. Eventually the number reaches 0. Right. So when the number reaches 0, then that's when this base case runs, right? On line 12. Then the recursion stops and the function stops. Right. Do you all understand what's happening here? So are all on the same page? Yes, Mr. Toops.
I have a question. Maybe we'll get to that, but can we do it with strings as well, besides numbers?
Yes, we can.
Oh, okay. We can create maybe like a list. Okay, then okay. I'm just picturing the whole thing.
Yes, we can with strings, any data type.
Any data type, but okay.
Yes. Now, okay, let me clear my terminal. Right. Right. So here, right, okay. So let me just copy this. Let me paste it here. Let me comment it out. Right. Now, if I, let's say, yes, Mr. Toops.
Okay. So this recursive and the base thing, are they not like substitute of when we're making a conditional statement, an if statement? Are they not like replacement for a leave or maybe the else statement? Are they not like a substitute in a way?
Let me. Our base case. It depends on what a function does, but the odds are most of the time you are going to be using an if statement.
Yeah, like since okay, some stuff, so that's why I just asked. It's okay. I think I get it. Yes.
Okay. Yes, Mr. Changa.
I don't know, Mr. Dubs. Are you not trying to ask that on line 35? Is it not? It's an else. It's an else condition. Is it?
No.
I don't know if I got that correct, Mr. Dubs.
Yes, like that. Is it
Line
line
35.
35 or yeah? That's actually
It's an else
my
statement actually.
well,
Sorry, go ahead.
not 35 per se, but actually You know, we could. I was thinking that maybe we could substitute the else statement. Otherwise, to be this number is equals to 0, then print done. We can just change around this code. In a way, that's what I was thinking, but I know it's kind of like far from it. But yeah, like maybe we'll make number is equals to 0 as an else statement. Then we run the code with if maybe number is equals to 5.
Yeah, exactly. We say if number is equals to 0, print done. If number is equals to 4, print 4 minus 1.
In a way, yeah, that's what I was thinking.
That's what you're trying to say.
Yeah.
If number is equals to 3, print 3 minus 1, something like that. I don't know. But I think that's what it's trying to say.
No, it can't work like that. No. Now, imagine if our number was something like this. How many if and else statements are you going to have?
What if we use the range? The range.
The range now depends. Yes, it's possible, but it's a long shot. It's a longer way of doing it. That's the nice thing about programming. There are a lot of ways to tackle a situation. You can choose the best way or the most suitable way to tackle a certain situation. There are unlimited ways of how you can handle the situation. So sometimes for you to choose the best one, you need to think what instead of saying okay our number is 5, what if the number is 1,000? What if the number is 1 million? Which method is going to handle a million numbers? So you should always look at the bigger numbers. So in that way, to make it easy for you to create systems that can handle a lot of users at the same time. Yes, Mr. Janga.
Yeah, sorry, just a quick one. I understand from line 31. Okay, when we first called our function and then you instead what do you call this? It's an argument, is it? Argument 5.
Yes.
Then that argument 5 is the one which is going to replace that parameter number on line 30.
Correct.
Then Python is going to that number is 5, so it's not going to print done, it's going to print number on line 35, which is 5.
Correct.
Then so from line 35 it is going to run it is going to run to line 36. After printing 5, that is when it's going to print 4.
Yes.
Because of line 36. So
That's
it runs
correct.
line 35 and then runs line 36 after that.
That's correct.
Then it keeps on running line 36.
After running line 36, right, it goes back to line 31. Now the difference is that the number is no longer 5, it's now 4 because we removed the 1 from 5. So it's going to run this again since the number is 4, so it means it's false, this is not going to run. Then it runs 35. Then it comes to 36, 4 minus 1, 3, and so on. You now get the picture.
Can you please repeat what you just said just now? That if it runs 5, it then goes to this code.
Okay.
Which code? Can you repeat that part? The last part.
Okay, let me run the code. Right. See, it printed 5, 4, 3, 2, 1 done, right?
Yeah.
So here we created our function, and then we called it. when you code the function, we passed 5 as an argument, right? So what it did, it checked if number is equals to 0, print done, right? If number is equals to 0, the number is 5. So which means what? It's false, it's not equals to 0. Since it's false, then it moves on to line 35. It prints what? The number 5. After line 35, it comes back to line what? 36, right? Now with line 36, it's now what? Calling this function again, right? And then it's just saying what? Number minus 1. If the number was 5, right, now we'll just subtract the number by what? By 1, which is what? Now 4. Then it checks again. No, it's false. It then prints what? The number. Then it comes again. It takes what? The number again and subtracts 1. Then, so are you getting the picture?
Yeah, you know what? I didn't see that this print and the count were indented. Or all along I was seeing it like it's there on the. It's not indented, and now I realized.
Yes, they're
I was
indented. They're inside the
wondering why it's still running the phone with that. But thank you. Big five.
So are you guys getting the picture?
So after running line, okay, from line 35, when it prints, it prints 5, then line 36 is the one which is going to print 4. That now it is printing 3. I understand the first scenario, but it just picked from line 38, it picked 5, inserted 5 into the parameter, then checked if the 5 is not equal to 0, then it printed 5, then it went line 36 and printed 4. Then does it keep on? So in other words, you're trying to say it keeps on running line 36 up until it gets to 0.
Yes, that's correct.
Hello?
Yes, that's correct.
Oh, okay.
So
Okay.
as long
It's all right.
as long as this base case is not met, then that means line 35 and line 36 are going to run forever. That's why here we said what? Our recursive function eventually needs a stopping condition, which is a base case. So in this situation, this is a base case. It's the one that ends the function. So without the base case, it will keep on running this forever.
Okay, so
and
line
ever.
30. Not just run once. Yeah, when you code the function, it's okay. I will try and go for the sake of time.
Okay, that's right.
We can we can proceed. Yes.
But are you getting the picture of what a recursive function is?
Yeah, I'm getting it. I'm getting it so much. I just wanted to confirm that line print number, it is the one that printed 5, is it?
That's correct.
Then line 36, it is the one that printed 4.
No. Line the number that printed 4, it's also line 35. Remember,
Exactly what I'm trying to say.
line 36 doesn't have a print function, so it doesn't print anything.
No, no, I get it. Thank you so much, Mr. Kumalo. On line 36, the function keeps on calling itself, but deducting and what?
By 1.
Yes, subtracting a 1. Then it
Exactly.
prints number. Then it subtracts another 1. Then it prints number up until it gets to 0.
That's correct.
It's okay. Thank you so much. Now I understand.
Okay, then that's great. Now, if we say let's remove this, right? What do you think is okay? Let's say it's 1000, right? This is another recursive function, right? What do you guys think is going to happen if we run the code?
So line 37 is a 0.
The what?
Line 37 is 0.
Line
Or we
37.
start a new function.
No, the recursive function is still here. This is another one.
Okay.
Okay. Yes, Mr. Changa.
Okay, here's my 2 cents. I think it is going to print 1000. It's going to go down to 0, and it's not going to stop. It's going to get to -1, -2. It's going to run up to -1 trillion. I don't know.
Okay, let's find out. Now running the code. See, are you guys seeing the terminal?
Yes.
Yes. See, it started at 1000 all the way down, and then we eventually got an error, right? Maximum recursion depth exceeded. Right. So this just shows you why a base case is very important. Right. So without the base case, then the function will keep on calling itself, and eventually Python will raise an error. So with the recursive function, it can't go to at below 1. It can go to negative. Right. Not by you to say -1, -2, -3, it doesn't do that. Right. So this is why a recursive
Well understood.
this is why a recursive function needs what? A reliable stopping condition. Right. So always remember that a base case is a condition that stops recursion, right? And the recursive case is a code that calls what? The function again, right? So which means in this situation, this is our base case, and this is our recursive case, right? So whenever you are writing your recursive function and you cannot clearly identify the base case, so you should stop and just rethink your function, right? You should always be able to identify the base case, right? So a base case is we can say is the most important part of a recursion of a recursive what function, right? Okay. Let's create a list students equals to, you can say John, Tadiwa, Nyasha, Simon, right? So if we want to print these students, we can also use a for loop, right? We can also use a for loop, right? But for now, I don't want us to use a for loop to print out these names. I want us to try and use what a recursive function, right? So, right, what I'll do is I'll create a function called print students. So I have what students and the index, right? So if index is equals to learn students, right, return, right? So I want us to print students index, right? Then I want us to call the function again, right? Students index plus 1, right? So then we call the what our function print students, then we say students 0, right? We are all together, correct? Okay. Okay, so now I'm saving the code. Okay, before we run the code, right, I want us to look at our function. So our function receives what? Two parameters, right? Students and index, right? So index is going to be what? It's going to be a number, right? So then we have what? If index equals to len students, return. So this is our what? Base case, right? So what this means that when this index reaches the length of the list, right? If it reaches the length of the list, we stop the function, right? So if the index reaches what? The length of the list, we stop the function, right? Then we have what? Print students index, right? So here we print the current student, right? Then we have what? Print students index plus 1, right? So this is our recursive what? Case, right? So this is our recursive case, right? So the function what just calls itself, but this time, unlike last time, right, we increase the index by 1, right? So now running the code. See, it's still printed what? John, Tadiwa, Nyasha, Simon, right? So here when you saw that the index is equal to length of the students, then it returned what? It returned nothing, then it stopped the function, right? So we used this len function to get to know how many values are inside what? Our list. So the recursive function moves through the list one position at a time. When it reaches the end of the list, the base case stops the recursion, right? So any questions? Any question?
Please check the inbox.
Okay. Yes, that is correct, Mr. Farai. If you write a function without a base case, right, it is wrong. It is very wrong. So your recursive function should always have a base case. So any question? Okay, so no question. Okay, so we all understand how a recursive function works. Right. So, right. Recursion is especially useful when a problem naturally contains smaller versions of itself. Right. When a program just naturally contains smaller versions of itself. Right. So you most likely use recursion when you're working with that with certain algorithms. Right. So we can use for example, if you're looking at the folders of your right, if you for example, if you write a script that checks the folders of your laptop, you can use that recursion because it's going to go through every folder one by one. Right. So it will just call itself to open that folder and do etc etc. Right. So if the other question that you guys might have, if a loop can repeat something, why should I use a function? Right. So, and that is a valid question and a very good question. Right. So most of the times you should always use a loop because a loop is a better choice and a much more efficient choice compared to what to recursion. You should not use recursion just because you can. So you should use recursion when the problem naturally fits what recursive thinking. When you say that, okay, for this situation a loop is not the best choice, then that's when you can use what a recursive function. Right. So any questions before we end today's lesson? Any questions? Yes, Mr. Janga.
It's not a question, Mr. Kumalo, actually. It's just a request.
Yes.
Yeah, the integration part is going to definitely, we are going to reach at a point whereby you also you are going to emphasize on the integration part. Is it?
Yes.
Because there's one thing that I have discovered about learning code. The problem always comes when you're now trying to come up with the real application, a real software. These concepts, independently, we are able to understand them and comprehend them and ask questions. It's just my polite request. I plead that I don't know. I don't want to encroach in your timetable, but I just hope, speaking on my behalf, the main objective for me taking this course was to be able to, at the end of the day, to be able to create, what do you call these systems, applications.
Yes, we're going to get to that point.
So I hope you're going to get there. I am sure there's a time where you're going to. Okay.
So for now, I want you
Yeah,
guys
it's
to
okay. It's
understand
okay.
the theory, the concepts, and know that there is this concept and this concept. So that when now you have to combine them, you can say, oh yeah, I remember we can use a for loop to loop over this. Then you can now think of how to loop over it and so on.
That's very true. Like what we did with the school management
Yes,
system. That was
yes, that's correct. Okay, so any question?